All right. So let's check your answers starting on page 9. Question number 1. I got it.
Yeah.
All right. So here we are. Question number 1. The only force that acts is gravity. Number 2. Does the acceleration of a falling object depend on mass? The answer to that is no. Remember, we saw in that experiment from Galileo, and we saw the one on the moon, where when you drop the two objects, the hammer and the feather, without any air, they both fall at the same rate. And that acceleration is 9.81 meter per second squared going down to the ground. Number 3, what is the rate of acceleration due to gravity on Earth? We just said that, 9.81 meter per second squared going down. Number 4, in what direction does gravity always cause objects to accelerate? The answer is down, towards the center of the planet. Number 5, if the initial velocity of an object is upward in the positive direction, what must the sign of the acceleration due to gravity be in a calculation? It's got to be negative, right? So we have to have a negative acceleration in our calculations. Number 6, a ball is thrown straight up in the air. At the peak of its ascent, what is it doing? It is stopping and changing direction of motion. Part B, what is the ball's velocity there? It is 0 meters per second. Part C, what is the ball's acceleration there? It is negative 9.81 meter per second squared. All right, let's go on to page 10. If a ball is accelerated downward at 9.8 meter per second squared, by how many meters per second does the object's velocity change every second? It changes by 9.8 meters per second every second. That's what 9.8 meter per second squared means. All right. Number 1 on page 11. Part A, how fast is the ball going after 3 seconds? It is traveling at 30 meters per second. Now let's talk about how this would be graded tomorrow on your test. It would be a 1, 2, 3, 4, 5, 6-point question. You would get 1 credit for giving me the correct equation off your reference table. 1 credit for correctly substituting in the given values. 1 point for coming up with the correct numerical answer. You would get 1 point for having a unit after every number that you listed. 1 point for having the correct sig figs on your answer, and 1 point for giving a direction if it were a vector problem. This one is not, so we would not have that point, so it actually would be a 5-point question. Okay, that's how these kinds of questions are graded, and that's how they're always graded on a unit test. So you want to make sure that when you're doing these questions, and all of this is listed at the end of the problem in parentheses. It says show all work, including da 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 da. That's all the stuff it's going to tell you to show. All right. This has 1 sig fig because 3 seconds has 1 sig fig. So 30 meters per second would be the correct answer if I wanted the speed. If I wanted the velocity, then you would say negative 30 meters per second or 30 meters per second going down. Part B, how far has the ball fallen in 3 seconds? So this would be 40 meters. The distance fallen is 40 meters. By the way, if you have a problem where you have to do algebraic manipulation, so like if I use this equation and asked you to find the time instead of the distance fallen, you're going to get another point for correctly manipulating it. Okay, so you have to always start with the equation off the reference table, and then you get another point if it asked you for the algebraic manipulation done correctly. This is the displacement. That is the distance. Number 2, part A, what is the velocity of a diver entering the water from each platform if he steps off the platform initially? Okay, so if I do this off the 5-meter platform, then their velocity when they enter the water is negative 10 meters per second. If they are falling off the 10-meter platform, then their velocity would be negative 14 meters per second. I'm doing this with 2 sig figs only because that went to the ones place, so I'm assuming that must have also gone to the ones place with 2 sig figs. And likewise, if I didn't do that, it would look like they both hit the ground with the same speed, which is not true, right? The higher you are dropped, the faster you're going to hit the ground. Part B, how much time does it take the diver to reach the water from each platform? So if I do it off the 5-meter platform, they're going to hit the ground in about a second. If I do it off the 10-meter platform, they're going to hit the ground in about 1.4 seconds. Number 3, how long does it take this rocket to reach the peak? It will hit the peak at 5.99 seconds, part A. Let's go to page 12. Part B, what is the total time of flight? You're going to double that time going up. That would give you about 12.0 seconds maintaining the sig figs. Part C, what is the peak height? It's going to go up 176 meters. Number 4, A, if we drop the watermelon and the pumpkin at the same time, which one hits the ground first? You should know they both hit at the same time. Part B, if the watermelon is thrown downward at 10 meters per second and the pumpkin's dropped, which one hits the ground first? The watermelon. And the reason is because its initial speed is not 0 meters per second if you're throwing it down. Ryder? No. If you just said 176 meters, that's good because it just said height. Part C, if it takes the watermelon 1 second to reach the ground when we throw it downward at 10 meters per second, how tall are the stands? So for this, you would list givens of VI as negative 10 meters per second, A is negative 9.81 meter per second squared, and T is 1 second. You're looking for D. So you're going to use D as VIT plus half AT squared. You're going to plug those values in, and you would get 15 meters for the height of the stands. It would have gone down 15 meters in that 1 second, and that would give you a height of 15 meters. How long does it take the pumpkin to reach the ground if we drop it from 15 meters? So here are your givens, your VI, your A, your D, and your T. It would take it 1.7 seconds to reach the ground if you just drop it. Okay, any questions through page 12 so far? Yes, Khalees? On which problem? 2A and B, okay. So in part A, remember we take a square root. And whenever you have a square root, there are 2 possible answers. There's a positive root and a negative root. So you have to ask yourself, which root do I need to answer this question? And by understanding that these things are, the divers are moving downward when they get to the water, that tells you it's got to be the negative root because it's going down. Down is a negative direction. Okay. And then that negative answer would follow through for these displacements because they were moving downward. They're displaced. They end up below where they started. So that's a negative displacement. Okay. Anything else you want to ask through page 12? Yep. I'll show you the work that I have for 4A. Oh, wait, this 4A, there's no work. You just have to know when you drop things from the same height, they always get to the ground at the same time. Just like the hammer and the feather from the moon experiment. Always the same time. Anything else you want to ask through number 12? Or through page 12? Okay, so the rest is multiple choice. Let's check your answers to the multiple choice. And then I'll give you see if you have any questions that you want to go over, okay? Number 1 is A. Number 2 is C. Number 3 is C. Number 4 is D. Number 5 is C. Number 6 is D. Number 7 is D. Number 8 is B. Number 9 is C. Number 10 is B. Number 11 is A. Number 12 is C. Number 13 is B. Number 14 is C. Number 15 is C. Number 16 is A. Number 17 is B. Number 18 is D. Number 19 is C. Number 20 is B. 21 is B. 22 is D. 23 is B. 24 is B. 25 is C. 26 is B. 27 is C. 28 is B. 29 is D. 30 is C. 31 is B. 32 is C. 33 is B. On the last page, 34 is B. 35 is B. And 36 is C. All right. Do you want to go over any of those multiple choice questions? Yes, Miriam. 12 and 13. All right. So let's take a look at those. 12 and 13. So these are about graphs. And we're giving you 4 graphs here. I want to know which graph represents the relationship between the velocity and the time for an object that is thrown upward. So when we throw something upward, I'm just going to sketch the velocity time graph here. It starts off with some positive velocity. It eventually stops, changes direction, and then speeds up in the negative direction. So I need a negative slope diagonal line. Which one has the negative slope diagonal line? C. Okay, number 13. Which graph best represents the relationship between the speed and the time if I have an object in free fall? So free fall, it's the same thing. It's C. You're just dropping, B. When you drop something, it speeds up uniformly. So I need a graph which shows the speed increasing at a uniform rate. That is B. Okay. Anything else you want to ask on any of the multiple choice? 18. All right. Which graph represents the relationship between the mass and the acceleration due to gravity? So is the acceleration due to gravity the value of G dependent on your mass? Does G depend on your mass or my mass or my calculator's mass? No, which means I need to see something showing it's constant. That value of G is dependent on the planet that you're on. That's it. What planet are you on? So the planet's not changing, so it's got to be D showing a constant relationship, that the mass does not affect the acceleration. Anything else you'd like to ask? Gianna? 29. Starting from rest, object A free falls for 2 seconds and B falls freely for 4 seconds. Compared to A, how far does B fall? All right. This was on your quiz for Unit 4A, and most of you missed it. Let's go over how we do a question like that. We know that when something is in free fall, it's always going to start from rest, and it's going to accelerate at a rate of about 10 meters per second squared in the negative direction. The negative tells me it's just going to fall. I am changing the time and asking how that affects the distance. So what I'm going to do is look up an equation which relates these variables. And the only equation we have on our reference table which relates those variables is D is VIT plus half AT squared. And the VIT is going to drop out, which shows me that the distance fallen is proportional to half the acceleration times the time squared. Now, we are not changing the value of a half, nor are we changing the value of A. So I'm going to ignore those and should therefore understand that the distance fallen is in proportion to the time squared. The time squared. So I want you to look at what we have here. We're changing the time from 2 to 4 seconds. So what does that mean? 4 compares to 2, how? It's what factor of 2? Double, right? That means it's twice as great. So if I put in a factor that's twice as big in here, I end up squaring that factor. 2 squared is 4, which means I'm going to get 4 times the answer I started with. Now you could calculate it if you want. Calculate the distance fallen in 2 seconds and compare it to the distance fallen in 4 seconds, and you'll find it's 4 times larger. 4 times larger, choice D. That is a quadratic relationship. So when you have a quadratic relationship, if you double something, the final answer gets 4 times bigger. 2 squared is 4. You have to square the factor. Anything else you'd like to ask about, please? Yep. So in number 23, we have a softball that we are throwing straight up in the air, and it reaches a maximum height of 20 meters. We're going to neglect air resistance, and I want to know what is the vertical speed when it hits the ground. Okay, so let's make a list of our givens. For this problem, I don't care about it going up. I just want to think about it coming down to the ground, which means that when it starts off at the highest point, its velocity is 0 meters per second. We know it's going to accelerate down to the ground at about 10 meters per second squared in the negative direction. I'm using -10 for multiple choice to make my math a little easier. And then I know the distance fallen is 20 meters, but since it's going to go down 20 meters, it goes up 20 meters, so it's going to come down 20 meters. I'm going to make that negative. I want to know the final speed. The only equation that we have on our reference table that helps us with that is VF squared is VI squared plus 2AD. So the VF is the square root of VI squared plus 2AD. If I wanted the velocity, I would put the negative sign out front. But since speed is a scalar, I don't care about which root it is. So I'm now going to go ahead and simplify this and solve. So that would be the square root of 2 times -10 times -20. 2 times 10 is 20. 20 times 20 is 400. Square root of 400 is 20. So I get a final speed of about 20 meters per second, which is letter B. Make sense? Okay, you also asked about 24, correct? So in 24, we have a rock that falls freely from rest near the surface of a planet, and the acceleration due to gravity on that planet is 4.0 meters per second squared. What is the speed of the rock after it's fallen? 32 meters. All right, so let's list our givens for this question. We know that it's being dropped from rest, so the VI is 0 meters per second. The acceleration due to gravity would be -4.0 meter per second squared. Gravity always pulls things down, doesn't matter the planet you're on. And it is falling through a distance of 32 meters. So the displacement is -32 meters. I'm looking for the final velocity, or the final speed rather. So again, based on those givens, I'm going to use the same equation. VF squared is VI squared plus 2AD. So the VF is the square root of VI squared plus 2AD. Since I want speed, I don't care about the root. The VI is 0. So the VF would equal the square root of 2 times -4 meter per second squared times -32 meters. So now I can go to my calculator, plug that in. 2 times 4 is 8. 8 times 32 is 256. Take the square root of 256, and you get a final speed of 16 meters per second, which is choice B. Anything else you'd like to ask about on the multiple choice? Yes, Miriam? 28. In an experiment that measures how fast a student reacts, a meter stick dropped from rest falls 0.20 meters before the student catches it. What is the reaction time of the student? So I did my circling and my underlining. My VI is 0 meters per second when I say I'm dropping it from rest. The distance that it's fallen would be 0.20 meters, but it is being displaced in a negative direction. What causes it to fall? Gravity. So the acceleration for multiple choice, I can use -10 meter per second squared. I'm looking for the time. Reaction time is time. What equation uses those variables from your reference table? D is VIT plus half AT squared. This one you have to manipulate for T. It's in two parts of the equation, so we have to simplify it. Since VIT is 0, the displacement is 1/2 the acceleration times the time squared. So the time is the square root of 2 times the displacement over the acceleration. So that's 2 times -0.20 meters over -10 meter per second squared. We can now go to the calculator and solve that. Square root of 2 times -0.2 divided by -10 gives me an answer for the time of about 0.20 seconds, which is choice B. You're welcome. Anything else? Kiara? I'm sorry? 30, yes. A ball dropped from a bridge takes 3.0 seconds to reach the water. How far is the bridge above the water? All right, so let's list our givens. The VI is 0 meters per second because it says dropped. We know the time, T is 3.0 seconds. The acceleration would be -10 meter per second squared. We're assuming this is on Earth. We're looking for how far, which is D. The equation from your reference table, which has those 4 variables, is D is VIT plus half AT squared. VIT is going to drop out. So D is 1/2 of -10 meter per second squared times 3.0 seconds, which must get squared. Half of -10 is -5. 3 squared is 9. So -5 times 9 is about 45 meters down it's going to go. So which answer matches that? Best, choice C. Anything else you want to ask about on any of the multiple choice? All right, so at this point, that means you're ready for tomorrow's test. Pen, pencil, ruler, calculator. Okay. Let's look at what you have to be working on here to get you ready for tomorrow and the big test at the end of the week on units 1 through 3. There's no additional written homework this week except finishing your quarter exam review packet. So the rest of your double period today is to work on finishing that packet. Finish that packet and make up work that you owe. Remember, if your name is up on my paper that's tacked to the board, you owe me something that is due this marking period, and that really should get done first before you do anything else. Finish making up work that you owe, and then you can work on finishing your quarter exam review packet, which is due Thursday this week. We're going to spend 1 period on Thursday reviewing for the cumulative test on units 1, 2, and 3. After you finish that, of course, you can work on your test corrections. Those test corrections are due Friday. They must include a signature on the correction sheet in order to get those points back. All right, any questions for me? All right, then I'm going to let you guys work on the work that you owe. You can check to make sure